So when I finished my intervalometer circuit board, I needed a place to store it. So I was looking around Thingiverse to see if I could find a box that could contain my project. And unfortunately, there weren't anything that would directly contain it. But I did find this really nice conduit box on Thingiverse, and I put inside of the uh, project, I put the link to it that I could use as a basis. So I took a look at it and decided, okay, this is what I need. And I stripped out the conduit information because I don't care about that. And I stripped out the terminal block information. And what I ended up with is doing a heck of a lot more coding to get everything I want in here. So I'm going to go ahead and start by describing, first of all, that this design is in a program called OPenScad, which is a parametric type of design program that lets me put in, well, I would say code of some type that will be translated into the item that I finally want to build. But before we go into looking at any of that, which most people here really don't care about, or maybe they do, I don't know, I'm going to go ahead and show you on the side over here. I built a customizer out of OpenS that shows the most common variables that I would change when I am making this particular box. And right over here, there's a thing that says DB25. Now, if I turn this around and I open it up a little bit to show you, see that? There's the DB25 connector. And that allows me to put the DB25 that I hard-coded on my printed circuit board into this slot and screw it in. However, if I don't want that, I could just click this button and it disappears. Now, if I go along here and I take a look, there's a DB9 connector that I use for this project to connect to my camera. And again, I put a button on this side here. So if you don't want that, you now have a solid box that can be used for your project. See? Now, down here, this is a mounting bracket. And the mounting bracket has a couple of holes that you can put screws in to screw it onto a wood or whatever. Or in my particular case, I use it for tie wraps. And I can tie wrap this to my tripod. And there's a couple of different ways that I can manipulate that. I can have the rim on the side, which is this one here. And you notice that there's no front rim, but the rim is on the side. Or if you want a plain box, I can hit none. And see, there's absolutely nothing on the side and it becomes a generic box. Now the top here, I designed because I use LCD displays. And this fits a 4-line display that is quite popular from either Temu or Amazon. And you can get rid of this if you want by just clicking that, or I can get rid of the top if you want by printing that. Now, other things that you can do is, I'm going to show you a couple of things I did. If there's the top is secured by 4 screws, but if you have a solid top, you can also just hit this and they'll generate 2 more supports inside of the box, and that will lock it down a little bit further. But I chose to usually get rid of that one. Now, because of the way that the parametrics work in OpenSCAD, I decided to do a couple of menu options here. You can see that I have the width of the box, the depth of the box, the height of the box as being parametrics that you can monkey around with, and also how thick the walls are. So I can, the default is 375, and let's say I put 5 here, and you can see how much thicker the walls became. Very, very, very good. Let me put 10 down here. So these numbers take place once you do your refresh. That's not right. How come that didn't go down? Oops, no, that's right. Nope, that's wrong. I'm doing the radius, which is not right. I'm sorry. Let's get the radius back to 10. There we go. And let's get this guy back down to 3.75. And that's nice. Okay, let's look at a little thinner wall and see what we got here. Oh, yeah, that's probably too thin. See? It probably would work for most people, but not for me. So I think, I use 3.75, and that's an awfully thick one. And that does increase the 3D printing time. But, it's up to you. Okay, now let's get back to parametrics. Since this is all parametrics, and I used the customizer, I now have a pull-down menu that I designed up here. So if I hit this default value, this is what the box looks like right off the bat. Now if you look at the bottom of the box, this LCD here is for mounting screws. So you can put the LCD in here and put the 4 mounting screws on. Very nice. I can go down here and I can go look at the Doppler sensor. Now this is the Doppler sensor box. You notice all of the parameters changed very nicely. And this has a top that goes on here, and the Doppler sensor gets screwed onto the front. I hope you can see that. The 4 mounting screws, 1, 2, 3, and 4. And that's for the Doppler sensor. The Doppler sensor goes inside the box and it's covered by this. And with the DB25 sticking out here, that then inserts directly into the other box. Now I'll show you a couple of the other boxes I made. This is the ultrasound box, and you can see how this is generic size, and this is for the ultrasound sensor that I have. I'm going to now switch over and I'm going to go to LiDAR, and this is the LiDAR box. Nothing big magical about that. The LiDAR screws up and mounts right on here. I had to have this hole here so that the connectors, which is on the outside of the LiDAR, can go onto the inside of my box. And then I also have an IR sensor, which is this one right here. Now, the IR sensor mounts on the inside of this box, right over there. And I have this tube that I made that goes on the front. So what that does is it blocks out any infrared detection from the sides and only out the front. So the cone of detectability, that I call it, is limited by the size of this tube. So once you click on that, that shows up. Now the tube is parametric as well, and you can see that in the code. And I'm not going to go through OPenScad coding because, for most people it's pretty boring. But I'm going to turn on the window for the editor. There it is. And this shows you some parts that I played with. And this is the second base right here. This draws the base of the box here. And if we take a look, we have X, Y, and Z dim, which correlates to this width X, depth Y, height Z. That's all of this information that's coming in. So that's passed into the system. And then you can do some if definitions. So if I passed in doodads with IR sensor, I will move away from center this amount, and I will draw the tube. And that's this tube that you're seeing right here on the side. So that's going to draw the tube. If I have doodads, anything but IR sensor, then nothing gets drawn at that particular spot. Then all the rest of it is the standard OPenScad. I'm not going to bore you. You can look at OPenScad online, and it's a great tool. It takes a little while to get comfortable with it, but it's powerful. Now, is it better than a drawing package like Fusion 360? Well, you know, to be honest with you, I like this. I'm a coder, and I have problems with Fusion 360. I really do. But if I probably set my mind to it, I probably could be quite good on it. There is a lot of complicated shapes that you can build up with OpenSCAD. And you can do the same thing with Fusion 360. It's your comfort level. For me, it's easier to do this and then put in all my modifications here. So, I mean, I just absolutely love the customizer. The customizer really makes it easy for me to just, when I'm saving this away, okay, I forgot to do this box. Okay, I'll just click up Doppler and bang, there's my Doppler sensor box, and I am ready to do a 3D print on that. So I can just say Doppler, and bang, there's my Doppler box for me. Or I can say ultrasound, and there's my ultrasound, and I can do a print of that. And if I don't like the shape or whatever of this box, all I have to do is just change the parametrics here, to whatever it is. So if I want the height smaller, down to 30, there it is. Okay. Now the problem I had is once I put the sensor in here, there were some pins sticking up. So you have to be very careful how much you really can do that. And just looking at this right now, 30 probably wouldn't work because it's really touching the bottom over here. So let's see if I do 35. That cures that problem. Yep. So now it moved this up just enough, and I think that would clear the circuit board on this particular one. So yeah, you can do a lot of playing around with this. Now, there's a couple of things about OpenSCAD I don't like. There's no measurement capability right now. Even though I am on a version that says they are capable of doing measurements, I don't have it. It would have made life so much easier if I could have come in here and made this measurement here between the circle and the base, and it says, oh, that's 3 millimeters. It's supposed to be X, and then I could change it. But without that, I do play a few games here figuring that out. But I think in a future version, they're going to come out with that. Okay, so that's my description of OpenSCAD, the way I use it. And like I said before, this is a vast modification of something that I found on Thingiverse. That's over here. So the user misery bot, he was the first one to put that box out. And this is just a remake of that, purging all of the inside of his boxes and changing it to suit me. So you can see that I modularized a lot of things, like the LCD that I use for my default. Let's go back to that one, get the default back up again. Click, click. The LCD that I use, I put in a module. The D-sub connectors, the DB25 and DB9, are also in a module. And then I have the PIR tube, which is that round tube that shades out the infrared, is inside of a module. And that's just a quick summary of what I've done with OpenSCAD to do my project for an intervalometer. And of course, this box can be used for a lot of other things. I have a GPS that I produced also, and in that, I use the same box, except I don't have the DB9 connector on the side because I don't really need that. One of the other things I did, which I don't have on this module, is I made a 1/4 by 20 connector nut that I can mount on the bottom of the box so that I can put it on a tripod. I should put that in this, but I haven't done that yet. All right, that's enough for now, and thank you for watching. If you have any questions or you want me to publish this somewhere, I can do that.